Hello viewers, welcome once again for the third part of our topic for the logarithms. We have already done two parts. The last part we did was about equations, logarithmic equations. I explained several ways by which you can try solve equations to do with equations. Okay, I was not really done with the whole explanation in equations. There's some few things remaining which I need to explain today. So I hope you listen and will cooperate. Okay. So today, first of all, there's still two more laws that I need to explain. I didn't explain that before because the laws actually are related to questions to do with the equations. And I'll begin straight away from the next law. Then I'll show an example of a question that relates to that. And by this I mean, there is this law, log A base B, which is equivalent to 1 over log B base A. Now, if you have a log base, this statement may be written as 1 over, then the base becomes the log becomes the base, just like I've shown it here. So there is an explanation of this, and this kind of law is used in questions, like if someone asks you, find the value of x, given that log x base 5 plus log 5 base x equals to 2. A simple question to start explaining with. First of all, with equations, and in my previous lesson, I said it clearly that you can only solve logs if the bases are the same. But clearly, from what I have here, I have base 5 base x, then there is a problem. So in case you have an equation where the bases are not the same, maybe you can think of this. Think of maybe this law. So looking at this law, first looking at these numbers, I see log x base 5 plus log 5 base x. There's something to do with the 5 factor there, which if I think well, and using this law here, then I can have something that is common, then which I can use to solve the equation correctly. So this is what you do in this case. Is there any way I can write this to the base of 5 using this law here? That's possible. So if I rewrite this statement here, it should be log x base 5 plus. Now this statement using this will be 1 over log x base 5 then equals to 2. Okay, then looking at this, you notice that now we have log x base 5, log x base 5, same basis. But the problem is I will not solve this question like I explained in the previous chapter. There is something to also notice here. There is log x base 5, log x base 5. Log x base 5 is two terms which are kind of common, just the same values. So once you get to this, next is, you say since there is log x base 5, log x base 5, use a number which will make it easier for you to solve this equation. So you bring in this, you say let log x base 5 be a number, another different term, value. So which is log x base 5 equals to 5. Then if log x base 5 equals to 5, log x base 5 equals to y, I substitute any place there is log x base 5, I'll place the value of y. So this would become y, then plus, this statement should be 1 over y, then equals to 2. So now I have a normal equation. So with this equation, I can work out to find the value of y. First of all, I multiply all sides by this y here. So that leaves me with the y squared plus 1 equals to 2y. Okay, then I can see a quadratic equation. But I have to write it in the correct form, which is y squared minus 2y plus 1 equals to 0. Then I'll solve it using the quadratic formula. This should be minus b plus or minus root of b squared 4ac over 2a. You know the formula, you know what the values a, b, and c are supposed to stand for. So now, the negative of b will be positive 2, plus or minus b squared, which is 2 squared, minus 4. A is 1, c is 1, over 2a, 2 times 1. Then eventually, this leaves you with 2 plus or minus 4 minus 4 is 0. The square root of 0 is 0. Then divide by 2. Then from this, it's clear that the value of y for this question is 2 divided by 2, which is the same as 1. But again, the question was find the value of x, not find the value of y. Y is just a value I came up with. So if you leave that as your answer, you just know it's wrong. So how do you get the correct value? Go back to the relation between this and y, which was let log x base 5 equals to y. So now I got the value of y, which is 1. Then I'll write log x base 5 was equals to 1. Y, sorry. But my value of y is 1. So I'll write 1 instead of y. Then remember the first thing we did in this topic, that first part of this topic. I said that learn how to change indices to logarithmic form, logarithms into indices form. So that said, I have log x base 5 equals to 1. Can I change this to indices? If you can remember that. And I remember saying that you'll have to use this concept elsewhere. So you can see now we're using what I had just explained. So this becomes 5 raised to 1 equals to x. Then it means the value of x equals to 5. Then we have solved the question. So notice that I use this law to change this term here into this form. And by so doing, the question could now be done, explained. It was now much easier working out than it could have been. So again, without knowing this law, maybe this sort of question could not have been solved. I'll do one more example. I can only do 1 or 2 examples because, of course, you understand time. Okay, the next example is 3 log x base 2 plus log 4 base x equals to 5. Again, just the same process. I've already explained most of the things, so doing this should be kind of faster. Now, there is a base 2 base x, but there is a 2 factor, I can see a 4. And I said that when you're doing questions, most of the laws that you did maybe before, you might need some concepts to come up with ideas that will help you maybe proceed with whichever questions you ask. So if I look at this log 4 base x, I can write this log 4 base x in terms of log 2. Okay, so this will be the same as log x base 2 plus this is the same as log 2 raised to 2 base x, then equals to 5. So I'm doing this because I want that x2 factor in my statement there. So we say that anytime you have a power, can be written as a coefficient. So this is 3 log x base 2 plus 2 log 2 base x equals to 5. But look at this, log x base 2, log 2 base x. That same law comes in. Don't forget our law. It was log a base b equals to 1 over log b base a. So that said, this becomes 3 log x base 2. I want to make this log x base 2. So for that to happen, then it will be 2 times 1 over. So instead of writing times 1 over log x base 2, I'll simply write 2 over log x base 2, then equals to 5. Then look at that. I have log x base 2, log x base 2. What did we say? When you have such a statement, you'll say, let this common term here be a value, a letter of your own choice. So this should be log x base 2, let log x base 2 equals to y. Then any place I see log x base 2, I'll replace the value with the y. So that said, let's go back to the equation. Anytime you see log x base 2, just write y. Okay, so this should be 3 y plus 2 over y equals to 5. So those log x base 2, 3 log x base 2, so I wrote 3y, which is this. 2 over log x base 2, 2 over y, that equals to 5. Again, simplify this, solve to find the values of y. Multiplying all sides by y, it will be 3y squared plus 2 equals to 5y. Quadratic, collect the like terms. So if you collect like terms for this, should be 3y squared minus 5y plus 2 equals to 0. Okay then, this is quadratic. Just like the other question, we solve this using the quadratic formula. Minus b plus or minus b squared minus 4ac over 2a, which will be 5 plus or minus 5 squared minus 4 times 3 times 2, then over 2a, which should be 6. So the answer for this should be 5 plus or minus 25 minus 24, that should be square root 1, then divided by 6. Therefore, the value of y in this case is two values. Y can be 5 plus 1, which is 6, divided by 6, that's 1. Or y can be 5 minus 1, which is 4. 4 divided by 6, that should be 2 over 3. I got the values of y. The question was not find the values of y. You're supposed to get the values of x. So again, go to that relationship between x and y. Then say, if log x base 2 was the same as y, and y is 1, then what's the value of x? Logs to indices, remember that, which should be 2 raised to 1 equals to x, then the value of x equals to 2. That's in the first case. That's when y is 1. There's still one more answer to be found here, because y can either be 1 or 2 over 3. So again, if log x base 2 equals to 2 over 3, how do you get the value of x? The same thing. The value of x will be x equals to 2 raised to 2 over 3. That is it. So you can use your calculator to get this in decimal form, even though this is still correct. Then the values of x are 2 or 2 raised to 2 over 3. That's it. So now, about that law, I'll use those two examples, but I leave you with one question to try at your own free time before I proceed to the next concept. So the question I want you to try is solve for x, given that 5 log x base 3 plus 4 log 9 base x equals to 21. So at your own free time, try solving that. Maybe you can let me know your answer in the comments. Now next, I've explained one more law. So since I began, I think I've done 5 laws. Addition, subtraction, law raised to a power. There was logarithm of base, and there's also the logarithm log 1 to any base, which was the same as 0. So now, one more law to go, then we look at the application and maybe some other few things to do with that. So I'll wrap this. Hope you wrote it. Consider this question. First, I'll explain, it's an explanation. Then from the explanation, I'll explain now how the law comes in. consider this from your form 2. If someone says x, 2 raised to x equals to 8, then you're asked to find the value of x. For someone who has done indices in form 2, this should be easy. So now, if you want to solve this, it will be 2 raised to x equals to, you write this in terms of the base 2. Then whichever the power will be equivalent to x. Anyway, 8 is the same as 2 raised to 3. So then once you have this statement here, then it simply means if the bases are the same, then the power should also be equivalent, kind of. So the value of x equals to 3. We know this from indices form 2. So this is a question which can be done by someone who is in form 2. But now, at this level, if you are asked, find the value of 2 raised to x equals to 7. Now, I don't think there is any way you can write 7 in terms of 2 raised to. So that's impossible. And this is where now logs come in. So if you want to solve this question, it will be, there is a law of logs that says that anytime you have such an index notation form of a statement, then the log of what is on the left is always the same as the log of what is on the right. So now, what you'll do for this question is you introduce logs on both sides, which should be log 2 raised to x equals to log 7. Now, once you do this, remember, it's find the value of x. You know the law that involved a power. So anytime you have a power, write it as a coefficient. So this becomes x log 2 equals to log 7. Then I want to get the value of x. Divide all sides by log 2. Divide all sides by log 2. So same logs will cancel out. So the value of x will be log 7 divided by log 2. And whichever answer you get, that is it. So I was using this to explain just the difference between what you did in form 2 and now how the question can be slightly twisted. And this is why this is further logarithms. So for this same question, I could have done it this way. Maybe, let's see if we can get that 3. Then it will be 2 raised to x equals to 8. This becomes x log 2 equals to log 8. That is introducing logs on both sides. So once I've done this, divide all sides by log 2, divide by log 2. This cancels out. I have log 8 divided by log 2. Now, log 8, log 2, you can even use the third law. Without using a calculator, you can still get the 3 because 8 is the same as 2 cubed. So this statement alone is 3 log 2 over log 2. Then the answer will be 3. Okay, so we want to do some few examples relating to what I've just explained. And like I always say, any examples that I use, there should be some slight difference in the different examples used. So as a student, be keen on how I'm trying to explain. Okay, I'll start by using a very simple one, just like the one I've explained. 3 raised to x equals to 11. The question is, find the value of x. So to get the value of x, like I said, introduce logs on both sides. So this should be log x log 3 equals to log 11. Then divide by log 3, divide by log 3. So the value of x should be log 11 divided by log 3, which is something approximately 2.1827. How do you do this? You just use your calculator. And remember that when you're giving answers for such questions, at least try and give your answers to at least, let's say, 4 decimal points. 4 decimal points would be okay. Don't give your answer to 1 decimal. That's the answer will be not so much accurate. So for more accuracy, make sure that the number of decimals in this sort of questions that we'll do will be around 4 decimal places. That will be okay. The second example, I want you to watch the difference in the examples that I'm using. 5 raised to x plus 3 equals to 7. That. Now, there is an extra number on the power. That's the only difference I see there. So again, nothing will change. It's the log of this equals to log of that, which would be x plus 3 log 5 equals to log 7. Then next, divide all sides by log 5 divided by log 5. So this cancels. X plus 3 equals to log 7 over log 5. Then using your calculator, find the value of log 7 over log 5. You get x plus 3 equals to 1.2091. Then now the value of x would be, collect like terms, 1.2091 minus 3, which is equals to negative, of course it's negative, 1.7909. That is it, negative. So that. So that's my second example. The third example, it is 3 raised to x equals to 2 raised to x plus 1. Now in this case, both the values are raised to powers. Unlike this, the value that was raised to was only one of the two terms. So in both cases, the numbers are raised to. So again, let's see how the process will be. If there is a slight difference, we'll know. So solving out that, again introduce logs on both sides. So logs introduced on this side should be x log 3 equals to x plus 1 log 2. Okay then, which would be x log 3. In this case, open the brackets. If I open the brackets here, I'll have x times log 2, which is x log 2, plus 1 times log 2, it will be log 2. So notice that we are supposed to find the value of x, and x happens to be in two different places. So in such a case, you connect like terms. That means values that contain the x. So this leaves you with x log 3 minus x log 2 equals to log 2. Then there is x, there is x. You're supposed to find the value of x. So next is factorize the value of x to remain with the x in one place. So factorizing this leaves you with x into, this becomes log 3 minus log 2 equals to log 2. Then again, we have already done logs. You remember this sort of law. You may simplify this. This simplified will be the same as x log 3 over 2 equals to log 2. Then on both sides, divide by log 3 over 2, divide by log 3 over 2. So this cancels. Then your final answer for x, in that case, should be 0.6131. Of course, use your calculator to find the value of x by dividing log 2 by log 3 over 2, or log 1.5. That is it. So my 3 examples showing different forms of numbers. You can see in the first case, it was kind of simpler. There was a slight change, and in this case, both two terms are raised to values. You've seen that. I hope it's clear. Okay, now I'll again leave you with one question on that concept, and try and do it following the rules of my explanation. So the question is 2 raised to 3x plus 1 equals to 5 raised to 2 minus x. It's almost the same approach like I did this question here. So try do that question, and if you can get this answer, I think it'll be okay. 0.6847. So try work out this question and get this answer here. So if you can't do that, it will be okay. Okay, next. Next is Next is this, consider this question. Consider this question. It's first of all explanation, then how a question may be asked on such will come in later on. Consider this question here. If you're told, simplify log 12 base 4. Simplify log 12 base 4. How is this supposed to be simplified? Then, in order to do this question, the process will be, let the answer for this be x. Let the answer for 12 log 4 be x. And already, just like I've explained, there are things, I talked about things and promised that you're supposed to know them because you may need them later on in the topic, and you can see how now that comes in. So just from this, it's very clear that I have something that is logarithmic, but if I can change this into indices form, I may have a statement with a clear x, then maybe figure out on how I can solve the question. So for this, if I change this in indices, it would be 4 raised to x equals to 12. But then again, look at this and just remember what we did some few minutes ago. This statement is exactly the same as things that I've been explaining some few minutes ago. So, how to solve the value of x? If it was in a form that you can do using form 2 concept, you will do that. But if it can't, then you just go back to what I've been explaining. So this statement here means I have to introduce logs on both sides, which would give me x log 4 equals to log 12. Then to get the value of x, I divide all sides by log 4, then log 4. Then it means the value of x equals to log 12 over log 4. Okay, now this way I want you to concentrate. You might choose to do this question by going through the process that I've explained, then use your calculator to get this value. But there's something I need to explain that may bring in something that can help you when it comes to such questions, and it might lead to the last law I talked about. Now, look at this statement carefully, then look at that. There should be some comparisons. This was log 12 base 4. But then, to solve this to get the value of x. But then this statement, looking at this, is the same as log 12 over log 4. Same values, log base, same values here. The only difference is it was log 4 to base 4, but now I've ended up having two logs here. Log 12 base 10, log 4 base 10. So then my law will be the easiest way to solve such kind of a question, if it may be, but always remember this process here. You can do this by saying, given log A base B, this is just the same as log A over log B. Might be necessary somewhere where the equations, maybe you had an equation where everything was the same base, but comes out that there is one number which has a different base, but it has a log on it. So you can simplify that value by simply doing this, then proceed. So anytime you see this statement, maybe this can be helpful. So I've already shown one example of a question that relates to this law that I've just explained. This should be my last law. I think by now I've explained around 6 laws. Or are they more? Maybe, I don't know. Yeah, I've explained around 6 laws. So now, I'll show one more example of a question which involves this law. Just one example. Then any other examples you can obviously just look at the questions and know. You know, you can't really explain everything as such. So the example I'd use is find the value of log 5 base 11. No, log 5 base 2 plus log 9 base 11. Look at that. So we learned the first law, which was law of addition. But remember, I stressed on this. I said that the law only applies if the bases are the same. But looking at this expression here, there is base 2, base 11. So you can't think of using the first law to solve this. And this is why I'm saying that when it comes to such questions, which won't allow you, use some laws that maybe you've learned thinking that they can apply, you also think further. So it's not always good to limit your brains just to one part of maybe things. So try to open up then things. So if I have different bases, the best thing I'll do for this is think about this law. Then the easiest, fastest way I'll do this question, this will be the same as according to this law, log A base B. I can simplify this on its own, simplify this to get the value on its own, then the two answers add together. So this will be the same as log 5 over log 2, then plus. This will be the same as log 9 over log 11. Then, using your calculator, log 5 over log 2 should be the same as 2.3219. 2.3219 plus log 9 divided by log 11, the answer should be 0.9163. Then add these two values. If you add those values, the answer should be 3.2382. That's it. So you see, I've used this law to solve out a question involving an expression. So this is what I'll do. I'll give you a question that I want you to try use this law here, and it will be a question in an equation solving the value of a unknown. Try do this, and I'm very sure that there should be somewhere that you might need to apply that law in one way or another. So the question is, find the value of x given that log 2x plus 3 minus log x minus 8 equals to log 8 over 2. So you see, the base here is 10, base is 10, and then the base is 2. So think of how you can solve this to get the value of x, and remember, try to consider the law that I've just explained when you're doing that. Okay, next. Hope you've written that. Okay, the next thing I'll explain is something relating to questions you did in Form 2, indices, but the difference is, in this case, the questions cannot be done by someone who has just done indices Form 2 because of two things. The question I'll do involves quadratic equations, which is way ahead of indices in Form 2. Then again, in some cases, some questions may involve you using the concept of logs, further logarithms, just like I've explained. So I think the first question will be kind of straight away. I don't even need logs, but maybe just quadratics. Then if there is any other question that will be different, we'll look at them. So now, consider a question like 3 raised to 2x plus 1 plus 5 into 3 raised to x, then minus 2 equals to 0. Consider this question. So the question is, find the value of x. So to get x in this question, will involve the following, but let me take you back to Form 2. From the laws of indices, there is this law, a raised to m times a raised to n, which is always gives you the answer, provided the bases are the same, add the powers, m plus n. Most people know this, but if you give someone this, then ask for this, there are very few people who can actually see how it's done. So focus, know that if I have 2 raised to 3x times 2 raised to 1, the answer is 2 raised to, because it's indices, same basis, multiplication, add the powers, which is 3x plus 1. But also know that when someone gives you a value like 3 raised to x plus 2, then know what this means. And the meaning of that is you can split this to have two terms in this. The first will be 2 raised to x, 3 raised to x. Then the next one is, since this is a power and this is plus, multiply, then 3 raised to 2. But then, instead of writing 3 raised to 2, for the sake of working out such questions, we may not really write this as such. Instead of writing it this way, I'll prefer someone writes 3 raised to x times 3 raised to 2, which is 9. Done. Okay, now that said, let me go back to my question, the question I'm supposed to explain. If I want to work out this question, first of all, you have to split this. And from what I've explained, it will be 3 raised to 2x times 3 raised to 1, which is actually the same as 3. Then plus 5 into 3 raised to x minus 2 equals to 0. So then after doing this, you'll notice one thing. And by the way, 3 raised to 2x is the same as 3 raised to 2x is the same as 3 raised to x times 3 raised to x. But in that case, I can just leave it 3 raised to 2x. So you'll notice this. After splitting this question in this form, you'll have a 3 raised to x, then 3 raised to 2x. These 3 raised to factor. One will be raised to x, the other one will be raised to twice the value. If it was 3 raised to y, this should be 3 raised to 2y. So go for the lower, which is 3 raised to x. Then say, let 3 raised to x be y. Let 3 raised to x be y. So this means any place I see 3 raised to x, I place y. Okay, 3 raised to 2x, like I've already said here, it's the same as y times y, which will be the same as y squared. So this statement will be y squared. Then times 3, then plus 5, this should be y, then minus 2 equals to 0. So if I multiply this, I'll have 3y squared plus 5y minus 2 equals to 0. Again, I can clearly see a quadratic equation. So I'll use the quadratic equation to solve for the value of y. So how do I solve this? It's simply using the quadratic formula, minus b plus or minus b squared 4ac over 2a. Then this might be a and c. So it's negative 5 plus or minus 5 squared minus 4 times a is 3, c is negative 2. Then over 2a. 2 times 3 should be 6. Okay, this is negative 5 plus or minus 5 squared minus 4 times 3 times negative 2 should be 49. The square root of 49 is 7. Then divide by 6. Which should be the value of y. We'll have two values here. The first one, negative 5 plus 7. Negative 5 plus 7 is positive 2. 2 divided by 6 is a third. Or the next one should be negative 5 minus 7. Negative 5 minus 7 is the same as negative 12. Negative 12 divided by 6, that should be negative 2. Once you get these values, go back to your statement late, which is, did I write late? Yeah, it's here. So let 3 raised to x be y. So go back to that, then say 3 raised to x equals to y. The first value of y is a third. So it's a third. To solve this, you can use two methods. If you want to use the concept in indices, you can write this statement in index form so that you have the same basis. And this should be the same as 3 raised to x equals to this, like 3 raised to negative 1. Then the value of x equals to negative 1. That's the first form. Okay, the next form is don't do this. We have just learned logs, and that's why these kind of questions come just after those people who have actually done the topic further logarithms. So from this statement, 3 raised to x equals to a third. Just like we learned previously, I'm looking for the value of x. I'll introduce logs on both sides. So this statement will read as 3 log x log 3 equals to log a third. Then divide by log 3, divide by log 3. This cancels out. If you use your calculator to find this, then the value should be negative 1. So either of the two methods. Not all questions will be in this form. So if you can do it this way, it's faster, I think, and most of the questions, if you're going to use this, will work, but this will not work for all questions. It will only work for values which can be written to the same base. Okay, there were two values. There was y equals to a third or negative 2. Now, let's look at y equals to negative 2. The statement was 3 raised to x equals to y, but the value of y is negative 2. This takes me back to the previous lesson I taught last. So if I was to introduce, I'll just explain after I try something. If I was to introduce logs on both sides, I'll have x log 3 equals to log negative 2. Do you remember log negative? If you listen to the previous lesson, you know that I said that there's nothing like this that exists. So because of that, this value here is not part of the answers that are required. So this, even if you try to look for the value of log negative 2 on your calculator, I don't think there is an answer for that. So this will not apply. So the correct answer will only be x equals to negative 1. For this negative 2 value, you leave it. Okay, I'll show one more example relating to this. And the next example is for this question. Three into 3 raised to 2x minus 28 3 raised to x, then plus 9 equals to 0. Same thing. Okay, for this example, I don't think there is any place I need to split things. It's kind of direct. So I can see 3 raised to x, 3 raised to 2x. So I'll say let, straight away, I'll say let 3 raised to x, the smaller value, equals to a letter of your own choice. I prefer to use y. So then, substituting y where there is a 3 raised to x, this should be 3 raised to 2x, so it should be y squared. So I'll have 3, then y squared, minus 28y, then plus 9, then equals to 0. Now, again, this is quadratic, so simplify, solve this to get the value of y using any method you can. I'll always use the quadratic formula. So using the quadratic formula, negative b plus or minus b squared minus 4ac over 2a. This leaves us with 28 plus or minus 28 squared minus 4, a is 3, c is 9, then over 2a, which is 6. That. Which should be 28 plus or minus, I'll work out the value of this. So the value of this is 26, then divide by 6. The value of 40 is in the brackets. Okay. Then from these two answers for the value of y will be 28 plus 26. 28 plus 26, that should be 14, 54. So I have 54 divided by 6, that should be 9. Or the next value, 28 minus 26, that's 2. 2 divided by 6 is the same as 1 over 3. So again, look at it. The question is almost complete. So next thing is get the value of x. You were never asked for the value of y. Y is a value I just formed. So it will be, if y is 9, and I said that 3 raised to x equals to y, then it's 3 raised to x equals to 9. For this, like I said, you can use indices if you wish. It will be 3 raised to x equals to 3 raised to 2, which is x equals to 2. Or, if you don't feel like using indices, you will write 3 raised to x equals to 9, but then introduce logs on both sides. So this statement will read as x log 3 equals to log 9. Divide by log 3 divided by log 3. This cancels out, then the value of x should be 2. That is it. Okay, that's the first answer. The next answer would be, considering a third, this should be 3 raised to x equals to a third. Again, you may introduce logs on both sides, which will leave you with x log 3 equals to log a third. So the value of x will be log a third over log 3, and the final answer will be negative 1. So that's it. I've done the question. You see, the reason I said this can be done by someone who is informed too, there is a place where you have to introduce logs. And this kind of logs, we've only explained these things to be done in further logarithms. For someone who is informed too, maybe you can do such kind of a question. So I leave you with 1 or 2 examples. On that, again try. The first example is, I want you to try this, 2 raised to 2x plus 1 minus 2 raised to x plus 4 equals to 0. The second one, 4 raised to x minus 10, 2 raised to x plus 16 equals to 0. Then the third example is, the question to try is 3 raised to 2x plus 1 minus 17, 3 raised to x minus 7 equals to 0. So please try, work out those questions, and I think up to that point we've come to the end of the topic, further logarithms. I may not have explained everything as such, but as a student you're supposed to do your own research, but I'm very sure that with the concepts I've explained since the first day, if you're very keen on them, then that should help you, and you should be able to go try out questions and work all of them correctly. Thank you for your time. See you next time.